Today on Capechi's Corner, we're going to look at solving systems of equations using Cramer's Rule. So there's a couple things we have to do before we start using Cramer's Rule. Okay? Each square matrix has something which we call determinant. And what that is, you can see, is if I take this row and multiply them, and I take this row and multiply them and subtract, that's my determinant. Okay, so let's try some. So I have 5 times 9 gives me, I'll write that out, 5 times 9, and I'm going to subtract 8 times negative 4. So that gives me 45, minus a negative 32 gives me plus 32. So my determinant is 77. Okay, let's try another one. 0 times negative 11, we love when we get zeros on these, minus 4 times 6. So I get 0 minus 24. So my determinant here is negative 24. All right, now we're going to work on something called the diagonal rule. It says third order determinants, which means a 3 by 3 matrices can be evaluated by using the diagonal rule. Okay, so what you're going to do first is if you look down here in number 3, you first have to rewrite the first 2 columns, rewrite them so you can kind of get those 3 diagonals there. Okay, that's the first thing you're going to have to do. And I have them kind of color coded because this is how you're going to multiply them. So I'm going to multiply 4 by 2 by 9. And then I'm going to add kind of that pinkish color, negative 8 times 6 times negative 4. And then I'm going to get plus 3 times negative 3 times 5. Once I get that, we're going to put them together. I'm going to subtract the other side going the other way. So let's do the other way. So now I'm going to show you. Let's erase all this first. I'm going to go in the other direction. And multiply this one. And then I'll multiply this one. And this one. Okay? So once I have everything, I'm going to get a value here. Right, I'm going to get a number, and then I'm going to go the other direction. I'm going to subtract it. So I have negative 4 times 2 times 3. And I'm going to add that to 5 times 6 times 4. And then I'm going to add that to 9 times negative 3 times negative 8. Okay, so when I do my first, what I have up here in pink, that gives me 72. And then I get positive 192 here. Then I have negative 45. So I put that together, I get 219. Now I'll do what I have in purple. So I get negative 24 plus 120 plus 216. That gives me 312. Okay, so to find the determinant, I'm going to take 219 minus 312. And I get negative 93. So that's the determinant. Okay? All right, let's move on to the area of a triangle. So what happens if you look at the diagram, the sample diagram here, okay? We have 3 different vertices, and this is kind of a quick way actually to find the area of a triangle if it's not necessarily on a 90-degree angle and you can't use Pythagorean theorem, okay, is use matrices. So here's the formula. I'm going to put a 1/2 up front. So we have these pairs, right? Each of these are coordinate ordered pairs. So it doesn't matter. Order of the vertices doesn't matter where you put them. The last column is going to be a 1. And then we'll go from there. We're going to use the diagonal rule. Okay? So let's see what we have. A zoologist tagged a tiger with a GPS tracker so that she could determine the tiger's territory. After several days, the zoologist determined that the tiger's territory was a triangular region. By using the coordinates of the vertices of this triangle, she can use matrices and determinants to determine the side of the tiger's territory. what is the area of the territory in kilometers, okay? So again, the order that I put the vertices in doesn't matter, but these are my 1, 2, 3. They're my ordered pairs. So again, I know that I have to rewrite those first two columns like we did before in that previous problem so I can use my diagonal rule. All right, let's see what we have. So I have, now again, I put them in a highlighter. Even when I do it, on paper, sometimes I just use a light pencil just so I don't lose my spot. So I have 0 times 12 times 1 plus 0 times 1 times -2 plus 1 times 4 times 8. So that gives me, we love zeros in here. It makes our life a lot easier. 0 plus 0 plus 32. Okay, now let's go the other way. So I have -2 times -2 times 12 times 1 plus 8 times 1 times 0 plus 1, and that got kind of erased a little bit, 1 times 4 times 0. So this gives me -24 plus 0 plus 0. So I have, my first diagonal was 32. And I'm going to subtract the -24, so I'm going to add 24. But again, remember a formula. I have to remember to multiply that by 1/2. So it equals 1/2 times, what's that, 56? So my area is going to be 28, but it's a word problem. So it's going to be 28 kilometers squared. That's the area of that tiger is roaming around. All right, let's finally get to use some Cramer's rule. So what happens with Cramer's rule, if you see, now you've been able to solve this linear system through substitution, through elimination, even through graphing. This is another way. Now, is this the way you probably would do it? Probably not. The other ones are quicker, but it's just to show you that there are a lot of uses for matrices, and especially using computers, okay? It says, right now, as you're going to look at the coefficients, right, the numbers that are in front of your letters, and then you're going to divide it by that determinant. Okay, so basically what happens, it's good, and it's probably easier to look at my example here. So what happens, I'm trying to find x. And what do I do when I find x? Just like what it says here in red, I'm going to replace my x values with my constants. Replace the variable you're trying to find with the constants. Then in this column, that's my coefficients for y. Underneath here, this is my determinant. You're going to use the coefficients for x and y. So that's why I have 5 and 3 and -6 and 4. Okay? So what I'm going to do now is I'm going to start multiplying. So I have 15 times 4. And I'm going to subtract -6 times -29. On the bottom, I have 5 times 4 with my diagonal minus 3 times -6. Okay, my top simplifies. If I put that in my calculator, I get -114. And the bottom, I have 38. 38 is my determinant. That's going to be helpful. We're going to use that again. So I have x is equal to -3. Now we're going to do the same thing with y. So again, my x values I'm going to use there, my x coefficients. So I have 5 and 3 in that first column. I've replaced my y coefficients with my constants. Okay, so I'm going to do the same thing. So I have 5 times -29 minus 3 times 15. Now, I've already found the determinant on the bottom, so I don't need to do that again, right? We know that that is 38. So I have 38 on the bottom. Okay, so I have 5 times -29 minus 3 times 15 gives me -190 divided by the determinant of 38, and I get -5. So y is equal to -5. Now, just like you did when you're solving systems using substitution or elimination, we can check it. So let's go back to our original problems at the top there. I have 5 times -3 minus 6 times -5. So this is our check step. And that gives me +15. which is true. That's what we want. And then if I do the second equation, I have 3 times -3 plus 4 times -5. And that equals a -29. So let's see if that's right. This gives me -9. This is -20. So I'm good. So I know right here that I have my final solution will be in coordinate form, -3, -5. Okay, great job with Cramer's rule today. Have a good one.